Hi class, and welcome to section 9.5, solving quadratic equations by using the quadratic formula. So for most of you, this is the very first time you've seen this, and really by the end of this section and chapter, it's probably going to be something that you just flat out memorize because you use it so much. To solve the standard form of the quadratic equation, ax squared plus bx plus c equals 0, we're going to use the quadratic formula, and here it is. So x, we're going to be solving for variable x in the equations. X equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. And that gives the solution of ax squared plus bx plus c equals 0, where a cannot equal 0. If a does equal 0, well, then this doesn't end up being a quadratic, just simply becomes a linear function, bx plus c, or mx plus b, if you think about it, equals 0. So example 1. Solve x squared plus 2x equals 3 by using the quadratic formula. So it says rewrite the equation in standard form. Okay, so x squared plus 2x equals 3. If you subtract 3 from both sides, what happens is that you get it set equal to 0, and that's what we want. Now we let a equal 1. We can see that a equals 1 in the equation. B equals 2. C equals negative 3. So when you use the quadratic formula, it's x equals, again, negative b, so negative 2, plus or minus, square root, parentheses 2 squared, minus 4 times 1 times negative 3, all divided by 2 times 1. So everything is plugged in appropriately, and whenever necessary, or really whenever you see negatives, I highly recommend you use parentheses. Just to remind yourselves that, particularly when you see, for example, something quantity squared without parentheses versus with parentheses, you could make a mistake there. We'll continue, so negative 2 plus or minus square root of 16 all over 2. They simplified, of course, 2 squared minus 4 times 1 times negative 3 to be 12, so 4 plus 12 is 16. Square root of 16 is 4. There will be two answers, though, because the plus or minus warrants that. Negative 2 plus 4 all over 2, or negative 2 minus 4, it's a typo, all over 2. Negative 2 plus 4 is 2 over 2 is 1. Negative 2 minus 4 is negative 6 over 2 is negative 3. So the final answer simply becomes negative 3 and 1. The set notation is fine, but you could also just simply write x equals 1 or x equals negative 3. Example 2. Solve x squared minus 6x minus 2 equals 0 by using the quadratic formula. And then it says round to the nearest tenth if necessary. For this equation, a equals 1, b equals negative 6, c equals negative 2. So we'll plug in our values accordingly. Negative of a negative becomes a positive 6, plus or minus square root of quantity negative 6 squared minus 4 times negative 1, all over 2 times 1. This entire quantity under the square root, we call it the radicand. This whole thing becomes, what, 36 plus 8. So there 44 you see in the radical. So 6 plus or minus square root of 44 all over 2. 6 plus or minus root 44 all over 2 simply becomes, well, this should be just plus, so I'll cross that off. There's a plus version, there's a minus version. Now if I were to go ahead and type this in, because it will be a decimal, 6 plus square root 44, divide that by 2. My first solution is 6.3, they rounded to. And then the other, of course, 6 minus root 44. And then divide that by 2. And that's negative 0.3. Those two solutions are great. We'll go with that. And as you guys remember from previous sections, we will sometimes get irrational numbers like this. Irrational meaning you can't write these two answers as fractions. Last problem for sure, those are nice answers because they are rational. Continuing on, exercises. Solve each equation by using the quadratic formula. Round the answer to the nearest tenth. So problem number 1, x squared minus 3x plus 2 equals 0. And what I'd like to do is open another sheet here because I probably won't have enough room to do many of these. You all should be using probably scratch paper as well. Alright, so we'll go ahead and set this up. So we'll go ahead and identify our A, our B, and our C. We go ahead and see that A is 1, B is -3, and C is 2. So x, what we're solving for, equals negative b, so negative of a -3, plus or minus square root of b squared, so -3 quantity squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times 1. This becomes a positive 3, and plus or minus square root. Let's think about how this radicand is going to take shape. -3 quantity squared is 9. 9 minus 4 times 1 times 2, or 8. So 9 minus 8, simply 1. Still all over 2. And we'll continue here by identifying that the square root of 1 is just 1. We are going to have two answers. Two answers take shape accordingly. We shall have 3 plus 1 over 2 and 3 minus 1 over 2. So my two answers, 3 plus 1, 4 over 2 is 2. 3 minus 1, 2 over 2, which is 1. And again, I'm okay with the way they wrote the answers, but I'm going to write my answers as such, and that should be just fine. Let's move on to problem number 3. Problem number 3. 16x squared minus 8x equals -1. First step, we want to set this equation equal to 0, so we'll simply add 1 to both sides. We identify a, b, and c. A, 16, b, -8, and c, 1. We go through the quadratic formula. X equals -b, so negative of a -8, plus or minus square root b squared, so -8 squared, minus 4 times a, which is 16, times c, which is 1, all over 2 times 16. We'll continue, so negative of a negative is a positive, so 8 plus or minus. Now we've got this radicand, in which if we square this quantity becomes 64, minus this quantity, well that's also 64. So 64 minus 64 is just simply 0, and that's then over 32, because 2 times 16, and we'll simplify that, and that becomes simply just 8 plus or minus 0 over 32. So interestingly, what's going to happen here is that you really won't be able to add 0 to this and get more than one answer. You're only going to get one answer, and that ends up being 8 over 32, or 1 over 4. Alright, so that's our final answer. I'll just do this, so x equals 1/4. Now if you recall, we do need to kind of put this into perspective. When we did graph quadratics for the first time, we did see 3 different answers. We saw a version where the parabola crossed the x-axis twice. That was the most commonly viewed answer. We now see 1, and we hopefully recall that we will see a parabola, of course, only cross the x-axis once. And the last solution set is no solutions at all. Let's move on to problem 11. Number 11 is a nice problem to follow with here. So let's continue. So we've got a quadratic equation, 2x squared plus 5x equals 8. I'll subtract 8 to set it equal to 0. And again, we'll identify a, b, and c. A is 2, b is 5, and c is -8. So x equals -b plus or minus square root b squared minus 4 times a times c, all over 2 times a. We'll continue, so -5 plus or minus square root. We'll have 5 squared, 25, and then we'll do the math here. It will end up being a positive, but it won't be really that nice of a number if you think about what 4 times 2, 8 times 8, so 64. So obviously that being not a perfect square, nor 0 in this case, like we saw in the last couple problems, 89. So we continue with this, using that as our radicand. And then moving on, or moving forward, we see here that -5 plus or minus square root of 89 all over 4 will yield 2 different solutions, in which I will write as such. So there's 1 and here's the other. Negative 5 plus root 89 over 4, and negative 5 minus root 89 over 4. You'll definitely need to type this into a calculator. Again, 89 not a perfect square. So we'll do that. I could type it in all at once, but I'll just show you the progression steps. So we've got here 1.1. That's the first solution, run to the nearest tenth place. And then our next solution, negative 5 minus root 89. And that then divided by 4, negative 3.6. Really, that's it. We saw, obviously, in the example problem that we could, in fact, have answers that are irrational, and this is also that particular type of result. We're going to go ahead and we're going to move on to the other side here. So page 30. Continuing solving quadratic equations by using the quadratic formula, but now looking at something called the discriminant. In the quadratic formula, again, we remember x equals this. The expression under the radical sign is b squared minus 4ac is called what we see known here as the discriminant. The discriminant can be used to determine the number of real roots for a quadratic equation. So for case 1, b squared minus 4ac, if that whole quantity, again, under the square root, is less than 0, there are no real roots. So we'll see maybe if you graph a parabola, not even cross the x-axis. Case 2, if b squared minus 4ac equals 0, there's only one real root, so the parabola would only cross at one particular spot. And then case 3, b squared minus 4ac is greater than 0, there will be two real roots. So, for example, state the number or value of the discriminant for each equation, then determine the number of real solutions of the equation. So 12x squared plus 5x equals 4. We write the equation in standard form by subtracting 4 first, just like before, so it's equal to 0. And then simply find the discriminant. There's no use of the entire quadratic formula if you're just finding the quantity of zeros or roots. So b squared, so 5 quantity squared minus 4 times a, which is 12, times c, which is negative 4, or 25 minus 4 times 12 times negative 4. I'm changing my signs, of course, but 192, which is then added to 25, and that's your discriminant, 217. Because this number is greater than 0 or positive, we say that there are two answers to the problem. Now, we could do the quadratic formula and find those two answers, but we stopped here because, again, all they wanted was the number of solutions. Part B, 2x squared plus 3x equals negative 4. Again, we will look at this by attempting here to set it equal to 0, adding 4 to both sides. We'll do that. Finding the discriminant, b squared minus 4ac again, so b, which is 3, quantity squared, minus 4 times 2 times 4, so 4ac. Do the math, we have 9, and then we have minus 32, which is negative 23, and because that number is negative, we see here that this problem has no real roots. So it's a situation where the parabola doesn't even cross the x-axis. Now this concludes our section 9.5. We will spend more time on the discriminant. These particular problems, as you can see below, will be assigned for homework, as well as page 29 questions. This will be announced in class.